Hey everyone, Mr. Fransky here. Today we're going to talk about the sum and difference equations and double angle formulas. So really what we're doing today is we're adding more tools to our toolbox as far as how we can use different things to prove trig identities. So let's jump in. So the first thing I want to do is just give you the sum and difference formulas that we're going to be talking about, just so you have them all in one spot. And then we'll talk about how they're proved and look at some examples. So just kind of want to start out, I'm going to go through these in the order that we're going to show them or prove them. So the first one we have is the difference formula for cosine. So the cosine of the difference of two angles, x minus y, is equal to cosine x, cosine y, plus sine x, sine y. So notice there's a subtraction here and addition here. And then the sum, so cosine of x plus y, so if you add two angles together, all that changes is the sign. So it's cosine x, cosine y, minus sine x, sine y. Okay, and like I said, we'll do some examples with that later. The second set is just the same thing with sine. So I'm going to start with sine of x plus y. Sine of x plus y is sine x cosine y plus cosine x sine y. So sine, notice the sign is the same, plus and plus. And we have sine, cosine, cosine, sine, whereas with cosine is cosine, cosine, and sine, sine. And then the difference, same deal, x minus y, going to be sine x cosine y minus cosine x sine y. Just trying to get these down, and we'll talk about how they're kind of useful later. And then the double angle formulas we're also going to talk about today. So the sine of 2x, so that would be x plus x, and you can kind of see, we can put it together right here, but it ends up being 2 sine x cosine x. Whoops. And then the last one, cosine of 2x. Cosine of 2x is cosine squared minus sine squared. And you can use Pythagorean identity, which we'll show in a second to do a couple more with these. This is the same as 2 cosine squared minus 1, or 1 minus 2 sine squared. Okay, so these are all the formulas we're going to talk about today. We're also going to talk about tangent, so the tangent of like x plus y, which you can really just get by doing sine over cosine, and also the tangent of 2x. So we'll see a couple formulas for those as well. All right, so let's take a look. We're going to start by proving this first one, that the difference is cosine, cosine plus sine, sine. So here's the y, right? You know, as you guys know, I always like the y. So this is definitely a proof hat proof. Okay, so that means that this is something you don't need to know, but I think it's really cool. So we're in the unit circle here, so we have a radius of 1. And I have two different angles here. Alpha goes all the way over here into the second quadrant. Beta is this small little acute angle. It goes right to here. So then the x and y coordinates for both of those here, we would be at cosine beta, sine beta, because our angle is beta. And then all the way over here at alpha, we'd be at cosine alpha, sine alpha. What we're going to be focused on today is this distance d right here between those 2 points. So what I'm going to do now is I'm going to take this angle, and I'm going to rotate it down so that this line ends up right on the x-axis. Okay, so I rotate it down so it lines on the x-axis. And this guy's going to come down into the first quadrant somewhere. And that picture would look something like this. And the cool thing, I'm going to erase my lines here. So the cool thing is that the angle in between them, so this angle right here, think about what that would be. Well, all the way over here is alpha. This guy is beta, so I'm taking that away. So that angle right there is alpha minus beta. So they've taken this triangle, just rotated it down so that it's sitting on the x-axis now, but that distance is still the same. So what I'm going to do is I'm going to make those two distances equal to each other, and then I'm going to end up solving for cosine of alpha minus beta, and we'll see what happens. So what I'm going to do is use the distance formula. Now, if you've forgotten the distance formula, remember if you have 2 points, you don't know the distance between them, you basically just use the Pythagorean theorem on like this imaginary little triangle right here. So if I'm that d, this is the distance of the x's, x2 minus x1. This is the difference of the y's, y2 minus y1. And then use Pythagorean theorem just to find that d. So this distance right here is going to be the square root of the difference of the cosines. So cosine alpha minus cosine beta squared plus difference of the sines, sine alpha minus sine beta squared. Cool. And the distance over here, which we know is the same, but we're going to just set it up, so then we're going to send them equal to each other. This distance is from 1, 0 to cosine alpha minus beta sine alpha minus beta, because 1, 0 is this point right here. So that distance would be the square root of, let's write this as cosine alpha minus beta minus 1 squared, plus, and it's just sine squared alpha minus beta. We don't have to worry about the 0, because if you subtract the 0 and then square it, you just end up with sine squared. Now, these two distances should be the same. So now what we're going to do is we're going to take these guys and do a little bit of algebra on the next page. So I'm going to have to make sure I get those copied right. So I know that the square root of it was cosine, let me make sure I get these, cosine alpha minus cosine beta, so cosine alpha minus cosine beta squared, plus sine alpha minus sine beta squared, has to be equal to that same distance over here. So that same distance, which is square root of cosine alpha minus beta squared. Whoop, not squared quite yet. Using a different pen today, and I have to keep changing it to an eraser. I'm sorry about that. Can't just flip it over. So minus 1 squared plus sine squared of alpha minus beta. And our goal is to solve for this cosine alpha minus beta. We'll see how it works out. So first thing I want to do is get rid of the square root, so I square both sides. And at the same time, I'm going to expand these out. So here we have cosine squared alpha minus 2 cosine alpha cosine beta. So I'm just like expanding this out, foiling. If I have 2 of these, cosine squared over my first, outside and inside will both be a negative cosine alpha beta, cosine beta. And then we'll have plus cosine squared beta. And then plus sine squared alpha. Minus 2 sine alpha sine beta. And then plus sine squared beta. And before I do the right side, because I don't want to get too scrunched up in here, well, actually it looks like I could probably do it okay. So I'd have cosine squared alpha minus beta minus 2 cosine alpha minus beta plus 1, and then plus sine squared alpha minus beta. Alpha minus beta. Okay. Now, I think we have lots of Pythagorean identity here. Let's see. We have cosine squared alpha plus sine squared alpha, that's 1. And then we have, let's see, cosine squared beta and a sine squared beta. So that's plus another 1. Then it looks like we have this minus 2 cosine alpha cosine beta, and then minus 2 sine alpha sine beta. And on the right side, let's see, we have cosine squared alpha minus beta, and we have sine squared alpha minus beta, so that's 1. And then we have plus 1 again. That's over here, this guy right here. And then minus 2 cosine alpha minus beta. And that's what we're trying to solve for. So it looks like we have a 1 plus 1 on both sides, so those are gone. And if I divide everything by negative 2, and I'm going to write this on the other side, so I'm going to divide both sides by negative 2. So we have cosine alpha minus beta equal to, so divided by negative 2, so we have cosine alpha cosine beta plus sine alpha sine beta. And that is our first identity. So it took us quite a while, but as we see, we have the exact first identity that we had, that cosine x minus y is cosine x cosine y plus sine x sine y. And where did it go? There it is. Okay, good. So, how is this useful? Well, if I want to find cosine of the difference of two angles, what I want to do is pick angles that I know. So if I want cosine of 15, I'm going to write that as cosine of 45 minus 30. So now using my formula, that is cosine 45 cosine 30 plus sine 45 sine 30. So cosine 45 is root 2 over 2. So root 2 over 2. Cosine of 30 degrees in that first quadrant right there. Cosine there is the long value, root 3 over 2. Plus sine 45 sine 30. Sine 45 is root 2 over 2 as well. Sine 30 is 1/2. So it looks like we have root 6 plus root 2 over 4. Cool. So we found cosine of 15. And so this formula is useful for things that are differences of nice values that we know on the unit circle. All the 15s now you could basically get. So what about the sums? The question there is, what is cosine of x plus y? Well, I'm going to write x plus y as a weird thing. I'm going to write that as cosine of x minus negative y. You might say, why the heck are you doing that? Negative, negative makes positive. But the point is, we have a formula for the difference. We don't have a formula for the sum. So this is going to be cosine x, cosine of negative y, minus sine x, sine of negative y. Plus. Okay. So now, cosine of negative y and sine of negative y. Let's think about that. So here's our positive angle. Here's our negative. Which is the same? I think it's cosine. So cosine doesn't change. But sine here is positive and here is negative. So sine is opposite. So cosine of negative y, I'm saying, is the same as cosine of positive y. You go down or up, doesn't matter. It'll be the same cosine value. So this is cosine x, cosine y. But sine of negative y, we said that's going to be the opposite of what it is above. So we're going to have minus sine x, sine y. Okay, and that was our second one. So not hard at all. So now we have a formula for cosine of the sum and for cosine of the difference. Let's see what we can do with sine. So we're going to use cosine to show sine. So we have a couple of things that are important for us to know before we jump into this. And one of them is we want to show that cosine of pi over 2 minus x is equal to sine x. So if you think about the graphs of these, here's sine. Let me go back and read you here. And then cosine, remember, starts at 1. Okay. So here's cosine. So now what we're trying to do is show that these are really out of phase by pi over 2. You can see that, because here's negative pi over 2, here's 0. If we slide it over, you can see it. But we're actually going to use the formula to show this. This would be cosine of pi over 2 times cosine of x plus, because it's a subtraction here, sine pi over 2 sine x. Well, cosine of pi over 2 is 0. So this whole thing's 0. And then sine of pi over 2 is 1, so that is indeed sine x. Works out. It also so happens, so this is going to be important for us to show sine. It also so happens that sine of pi over 2 minus x is equal to cosine x. That one takes a little bit more thinking as far as reflecting the graphs, but you can take my word for it on this one. So what we want to show now is we're going to find a formula for sine of, what do I do? Sine of, let me see which one we're going to do. Sine of x plus y. Okay, so sine of x plus y, I could rewrite that as, because sine of x is equal to cosine of pi over 2 minus x, this would be cosine of pi over 2 minus parentheses x plus y. Now we're going to rewrite that as cosine of pi over 2 minus x, and then we subtract y. And now we can use our cosine formula on this. We'll have our formula for sine x plus y. So this is going to be cosine pi over 2 minus x, cosine y, plus sine pi over 2 minus x, sine y. Now let's put the pieces where they belong. Cosine of pi over 2 minus x, we said, is sine x. This is sine x, cosine y, plus sine of pi over 2 minus x, we said, is cosine x. And then the last part will be sine y. And that is exactly the formula we had. So sine of x plus y is sine x cosine y plus cosine x sine y. Very cool. And the difference, so let's see if we can write that one down. So we have sine x plus y is equal to sine x cosine y plus cosine x sine y. There we go. Okay, so then the difference, sine of x minus y, I'm going to rewrite that as sine of x plus negative y, because we have a formula for sine x plus y, so let's just use it. So that's going to be sine x cosine of negative y plus cosine x sine of negative y. So back to our unit circle first quadrant. well, first half, I guess. So if you have a positive angle and a negative angle, we said this before, cosine doesn't change. Sine, they'll be opposites. So the cosine, we said, doesn't change. So I can write this as sine x cosine y. And then the opposites are going to be the sign here. So we have plus, nope, it'll be minus. There we go. Oop. So it'll be minus, because I'm going to pull that sine of negative y out to the front. So we have minus cosine x sine y. So you may notice that the sign changes. That's kind of one way to remember it. And with the cosine, you don't have any change because it's both on the right. And cosine, you're going to have a change of sign in the middle. We'll get to a trick to remember that in a second. So double angles for sine and cosine. So we want now is like cosine of 2x and sine of 2x. Let's start with sine of 2x. So sine of 2x is sine of x plus x, which is sine x cosine x plus cosine x sine x. And you'll notice that the order here is kind of mixed up, but they're both the same. So this is just 2 sine x cosine x. Cool. And then cosine 2x. Cosine 2x is cosine x plus x. And cosine x plus x, that's cosine x minus sine x, which is cosine squared x minus sine squared x. That's cool. Awesome. Now, one of the ways that I remember it, so this is my memory trick, is that I know cosine of 2x has something to do with a cosine squared and a sine squared. They can't be added, because if they were added, they would always be 1. But the cosine of 2x is not always 1. So it makes sense to me that this subtraction means cosine minus sine. Cool. So one of the interesting things about cosine is, before I get into more interesting things about cosine, we're going to do an example with sine of 2x. So we're going to show that sine of 2x over tan x is 2 cosine squared. Well, sine of 2x, the only thing we have for that is 2 sine x cosine x. We're going to divide by tan x, which is sine x over cosine x. And now if we do a little bit of multiplying, so we have 2 sine x cosine x. Let's do multiply by cosine x over sine x. Sines go away, and we have 2 cosine squared x. Cool. Not too bad. Now, with cosine, you have a couple more choices. So we had cosine of 2x. We told us it was equal to cosine squared x minus sine squared x. But whenever you have those squares there could be something going on with factoring or Pythagorean. So no, because Pythagorean is sine squared plus cosine squared equals 1. So I could write this as sine squared equals 1 minus cosine squared. Or I could write it as cosine squared is 1 minus sine squared. So if we use those and sub them in here, excuse me, what we can do is, so cosine squared is 1 minus sine squared. So another way I can write this is 1 minus sine squared x minus another sine squared x, which is 1 minus 2 sine squared x. So another way I can write it just in terms of sine. I could also do it just with cosine. So we change that sine squared to a 1 minus cosine squared. So we have cosine squared minus 1 minus cosine squared. And that would be, let's see, 2 cosine squared minus 1, because the negative would distribute in here. So 2 more options that you can do for cosine of 2x. Kind of cool. So, which one do we use? Well, I would suggest you put the eyes on the prize. So, cosine of 6x, we look over here, we see a 3x there. I'm going to show that it's 2 cosine squared 3x minus 1. So, cosine of 6x, I'm going to write that as cosine of 2 times 3x, because that's going to give me this 3x over here. So that is 2 cosine squared 3x minus 1, because if this 3x was anything like, this could be like 2u or something. Just throws it right into 2 cosine squared 3x minus 1. So it's a one-step proof as long as you can see that you can break that 6x into 2 times 3x. We also could have done that as cosine squared 3x minus sine squared 3x, but then we would have had to done an extra step to get it back to here. now we're going to take a look at tangent. So tangent, if we think about the sum formula, remember that tangent is sine over cosine. So sine x plus y over cosine x plus y. And if we use our formulas for that, so sine of x plus y is sine x cosine y plus cosine x sine y. And cosine x plus y is cosine x cosine y minus sine x sine y. Now, we could just plug everything in here, but it can be kind of annoying. So what we're going to do is we're actually going to multiply this just to get some stuff to cancel out. On the top and bottom, we're going to do 1 over cosine x cosine y. The bottom as well, 1 over cosine x cosine y. Now, this should cancel out all kinds of stuff. On the bottom's actually easier. We'll do that first. Cosine x cosine y divided by cosine x cosine y is 1. Sine x sine y over cosine x cosine y, that is tan x tan y. And then on the top, if we divide by cosine x cosine y at the beginning, sine x over cosine x is tan x. And cosine y over cosine y is 1, so we don't have to worry about that. And then plus cosine x over cosine x is 1, sine y over cosine y is tan y. And that is our formula for the tangent sum. And the tangent difference, tan x minus y, is just tan x minus tan y divided by 1 plus tan x tan y. So these are formulas you don't need to know. You don't have to know tangent. It's just kind of cool that there is also a formula that works with tangent where you only have to use tangents in the formula. Kind of cool. So the other thing with tangent, you can also do it with a double angle formula. So if I did tan of 2x, so that up here would be 2 tan x, because you have tan x plus tan x, and then divided by 1 minus tan x, or 1 minus tangent squared x. And there's not a nice Pythagorean that changes that. So that's another formula that you don't need to know, but just kind of some cool ones that use tangent. All right, so last I want to teach you the cheer. So this is something that especially Miss Johnson really enjoys. But the cheer has to do with remembering sine and cosine and sum formulas. So sine x plus y, remember, is sine x cosine y plus cosine x sine y. And cosine x plus y is cosine x cosine y minus sine x sine y. And so the way that you can remember this is, if you want to do the cheer, get some pom-poms out. And this is the cheer. It's not that hard. It's sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay? So I'll write it out. So it's sine, cosine, cosine, sine, cosine, cosine, sine, sine, and the last sign is S-I-G-N. So sine, cosine, cosine, sine, cosine, cosine, sine, 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 because the sign here is different from the one on the inside. For sine of x plus y, it's the same. Cosine, it's different. So sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Still, I have BC calculus students that do this every time they see some indifference. They cheer this out. So if you like it, great. If you don't, not a problem. So here's kind of a summary. Remember, the tangent ones you don't really need to know. But they're kind of fun, and it's cool how we proved them. But the sine and cosine, you are responsible for those, and the double angle formulas as well. And remember, the way I always remember it, I remember the cosine squared minus sine squared for cosine. And that helps remember this is cosine cosine minus sine sine. Okay, kind of gets me this guy. And then cosine of sine of 2a is 2 sine cosine, which means it must be sine cosine plus cosine sine. Because if they're the same, then when you add them, it's just 2 of them. And that'll help you out. So your homework is the yellow worksheet. The yellow worksheet has to do with sum and difference formulas. And then, especially for the juniors, if you're going to be missing MCAs, make sure you get the gold. If you're missing math for the MCA test, make sure that you're getting the gold sheet. And we'll be doing that over the next couple days. And I will check them when we all see each other in a few days. So make sure you're checking the Schoology calendar. I love you guys. That's why I'm here. Have an excellent day.